Good morning, this is your Stat Sensei, Mr. Spensei, and in this case, in this video, we're going to talk about the normal distribution, and we're not going to be working with z-scores directly, we're going to be working with actual values. So we'll work with an actual value and convert it to a z-score, and from there find the probability. I want to look real quickly at our recipe for success. Name the distribution. We're going to be working with normals and define x. It says let x equal the number of. It'd be better off if we said let x equal whatever we're looking for. And then from there on, I'll walk you through this. It's going to be much the same as working with the z-score. We'll need to write our probability statements, etc. So here's our prompt. Suppose the ages of adults taking a business class course for the last 5 years at a local college are normally distributed in the graph shown below. So real quickly, I see my mean is 36. All right. So my mean is 36. And I notice 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below. So, what's the difference? It looks like my standard deviation is actually 3 because we're changing by 3 in each case, and we have plus or minus 3 standard deviations. So we have a mean of 36 and a standard deviation of 3. So with that said, we can sit there and figure out this next part. It says 68% of the adults taking the business class are between plus or minus 1 standard deviation, 33 and 39. 95% are between 30 and 42. And then 99.7 are between 27 and 45. And just to make a note, once again, our mean happens to be 36 and our standard deviation is 3. Okay. The first thing, we want the probability that x is less than 27. Well, first off, we need to define x. We're going to define it one time. Let x equal the age of a person, of an adult, taking a business class. And really, it's the age of the adult taking the business class at the local college. But we have the probability that x is less than 27. Okay, so I'm going to draw my picture. We have a mean of 36. 27 is somewhere down here. And I'm going to write down my z-score formula, and I'm going to plug into it. All right? And we want the probability that z, this is less than, so we'll keep a less than, 27 minus the mean. Our mean is 36, and our standard deviation in this case is 3. Now I can run this as a norm CDF, and I'll get my answer, but then I have to calculate the z-score by hand. So I'm going to go somewhere else on the calculator. All right? I'm going to do something else. I'm going to go to stat, test, z-test. Make sure stats is highlighted. Mean was 36. Standard deviation happens to be 3. Our x is 27. We only looking for one individual, so this is a 1. And we highlighted a less than was what they asked for. So the probability that z is less than -3 equals 0.0013. All right. The probability that x is greater than 39. So probability x is greater than 39. I can go right here. And we're looking for this. So plugging in, we want the probability that z is greater than 39 minus my mean of 36 over my standard deviation of 3. So stat, test, z-test, which is the first one, excuse me. mean of 36, standard deviation of 3, x is 39. We have a value of 1. Make sure we're shading up. And we get 0.15865. I want to do this one more time. I just want to show you something. Stat test, Z test. We're going to run it. We're not changing anything, but instead of calculate, we're going to ask it to draw it. Well, there it is. It drew it for us. Okay. So the probability that Z is greater than, and stat test, Z test, calculate. Probability Z is greater than 1 equals that. All right. Probability that X is greater than 30. Well, 36 is my mean, so still down here. And we're looking for this. So we want the probability that Z is greater than 30 minus 36 over 3. Have to pay attention to what those signs say because it'll change the probabilities a lot. Stat test, Z test, make this a 30. We already have it shading up, so we're good there. And we have the probability that Z is greater than negative 2. Equals 0.9772. All right, the next one. Probability that X is less than 42. Wow, that's going to be a really small number. Oh, no, it's not. It's going to be a really big number. It's a less than 42. So we're above the mean. So we're up here. And this is 42. And that's my X. So we want the probability that Z is less than 42 minus 36 over 3. And we want it to be a less than. Make sure make that change. And the probability Z is less than 2. 0.9772. Probability that X is less than 33. Our mean is 36, so 33 is below it. So we're shading this area. So we want the probability that Z is less than 33 minus 36 over 3. Stat test, Z test. Changing that to a 33. We already have it shaded less than, so that's good. So the probability Z is less than negative 1 equals 0.1586. Probability that X is greater than 45. So the probability X is greater than 45. We still have our mean at 36. 45 is above it. That's our X. And we want to shade this way. So the probability that Z is greater than 45 minus 36 over our standard deviation of 3 equals probability Z is greater than 3 is 0.0013. Probability that Z is greater than 0.00, messing up. Change colors. Probability z is greater than 3 equals 0.0013. All right, now it's asking us to calculate over an interval. So we need to draw an interval. In this case, we have 39 over 45, or 39 to 45. We're still working with our same mean of 36. And we have a standard deviation of 3, but we're starting at 39 and we're going to 45. So we're looking for this area in between here. So I need to do two probabilities because basically I'm going to start with the 45 and then do the 49. So the probability that 45 minus 36 over 3, excuse me, probability that z is less than 45 minus 36 over 3 minus the probability that z is less than 39 minus 36 over 3. All right, because we need the z-scores. There's a quicker way to do this, and I'll show you in just a moment. But we need our z-scores, and that takes a while. Stat test, z-test. My upper z-score is 45. We have less than, and that's what's on the probability statement. So 0.998. So the probability that z is less than 3 minus the probability will come up back to this. So I'm going to write off to the side 0.9986, 0.9986 minus. So the probability that it says then we go second vars. We have to calculate the other z-score. The other z-score is 39. Oops. Stat, test, z-test. This is at 39. And the probability z is less than 1 is 0.8413. The probability minus the probability of z is less than 1. And that equals the 0.9986 minus the 0.8413. And so now we need to subtract those. 0.9986 minus 0.8413 gives us 0.1573. Now I said I was going to show you the shortcut. The shortcut has a benefit of being fast, but it doesn't give you the z-scores. And if you're doing the FRQ, you're going to need the z-scores. Now you don't have to for multiple choice. So second vars, normal, CDF, lower bound. Oh, my lower bound, what was it? 39. My upper bound, 45. My mean is 36. My standard deviation is 3. And 0.1573, which is exactly what we got, but I don't have the z-scores to show, which I have to show those on a free response, which is why I'm approaching it this way for this particular set of notes. Okay, so we have 27 to 33. So we're at 36. We know 33 is below that, and we know 27 is below that. And we're looking for that interval right there. So probability, we always start with a high one. Probability that z is less than 33 minus 36 over 3 minus the probability that z is less than 27 minus 36 over 3. So stat, test, z-test. Starting off with the 33 because that was the higher number. And we end up getting probability z is less than negative 0.1. Z is less than -1. When we say that probability is 0.1586 minus the probability that Z, we got to calculate this one, stat test, Z test. And now we're changing it to 27. And we get probability Z is less than -3. And that probability is 0.0013. And if we subtract those two, 0.1586 minus 0.0013, we get 0.1573. And that's if we have to do an FRQ. If I were doing a multiple choice, I just go second vars, normal, CDF, lower bound, 27, upper bound, 33, mean of 36, standard deviation 3, boom, 0.1573. Definitely faster, but if it's an FRQ, you got to show those Z-scores. All right, last two. Probability that 27 is less than X is less than 30. So once again, we start off with a higher value. Well, I'll draw the picture just to be consistent. There's my mean of 36. 30 is somewhere down here. 33 is 27 is a little further down here. So I'm looking for that. And we start off with a higher value. So we want the probability that Z is less than 30 minus 36 over 3 minus the probability that Z is less than 27 minus 36 over 3. And to make this quick, and because we're running out of time, I'd show you, no, let's go ahead and do it right. Stat test, Z test, mean is 36, standard deviation is 3. This value is 30. So the probability Z is less than -2. Do that. Probability that Z is less than -2 minus the probability that Z, and we'll come back to that. But probability less than -2 is 0.0227. And stat test, Z test. And this time we're working with 27 because that was our lower bound. And probability Z is less than -3 is 0.0013. And 0.0227 minus 0.0013, 0.0227 minus 0.0013 equals 0.0214. That's the long way for an FRQ, stat test, or excuse me, second vars, normal CDF, lower bound 20, lower bound is 27, upper bound is 30. 36 is 33, and we get 0.0214, so we get the same thing. Last one. So both of our values are above our mean of 36. Our mean is 36. So we're at 42 and 45. And I'm looking for those values. So the probability that Z is starting with a high one, 45 minus 36 over 3 minus the probability that Z is less than 42 minus 36 over 3. So doing the high one first, stat test, Z test. This is 45.9986. And we're at 3. So the probability that Z is less than 3, and we get 0.9986 minus the probability that Z is less than stat test, Z test, 42, 0.977. Oops, probability Z is 2, and that is 0.9772. When we subtract those, 0.9986 minus 0.9972, and we get 0.0014. And if we go to the normal CDF, second VARs, normal CDF, lower bound 42, upper bound 45, we still have a mean of 36, a standard deviation of 3. And somehow or another, I have an error. So let's go back and check this thing. Stat test, Z test, make that a 45. 0.9986, close enough. Stat test, Z test, change this to a 42. 0.9772, 0.986 minus 0.9772, 0.0214. All right, I just wrote it down. I don't know what I did, but this is 0.0214, which is what we got when we did the norm CDF. All right, I appreciate you watching, and I hope to see you on the next one. Thank you.